Hello everyone. So from today we'll be starting a new series on Java programming. So this will be from very basics beginner level to advanced level. Okay, so now let's get started. So what we'll be covering is we will be learning what is Java, why is it still needed or why is it so popular and what are different programming languages, what is an algorithm, what is a syntax, everything about Java in detail, about JVM bytecode. So this is what we'll be discussing. Okay, so now first question is what is a programming language? So, first of all, let's think about what a human language is. So, languages like English, Hindi, Telugu, all these languages are natural languages and not computer languages. So, we as humans, to communicate, we have to have a language, right? In order to tell something to someone or listen what the other person is saying, we have a human language. So, all these English, Telugu, Hindi are human languages. Similarly, if you want to tell something to a computer to do something, right, we need another language for that, correct? So there is something called as a machine language. Okay, I'll tell you what a machine language is. So basically, computer does not understand your English or Hindi or a human language. Computer only understands zeros and ones, which is your binary, which represents the electronic states which are on and off. So computer only understands this. So that's the machine language which computer understands, which is basically zeros and ones. Now there are programming languages like Java, C++, Python, which acts like a bridge between the human and the computer. Okay, provided you have an extra layer which is a compiler. Okay, so what this compiler will do is it will make your human readable high level programming language, converts it into a level low level code, and then that code is understood by your system and it will do what you're asking to do. So this is at a high level. Okay, so let's move on. So what are the different types of programming languages? So there are three types of programming languages. One is a low level language or machine level language, the second is assembly language, and the third is high level language. Okay, so let's start with what is a low level language or a machine language. It is simply bunch of zeros and ones. What computer understands at the most simplified lowest form. So basically zeros and ones is what machine language means. So computer can run it very fast without a translator or an interpreter. Since it only understands on and off states, right? So it is very tedious and complex for humans to write this code which is in zeros and ones directly, right? That's why we need something better. So then came your assembly language. Now what is assembly language? So these use some symbols. Now symbols mean instructions like add, restore, something like this. Each of this is called as a symbol, and we use this to do certain operations. Okay, so these are better when compared to your machine level zeros and ones instructions. Okay, so an assembly language, okay, if you write the code in assembly language, you will need an assembler in order to convert the assembly language code into your machine code. Okay, so then for example, there is an instruction in assembly language called store one at A, store two at B. So this is an example. That's how a machine language looks like, which is slightly better than your a low level language. Now, people over the period of time thought that even this is a bit complex for the humans to write code, so they came up with a high level language. High level language is pretty much very simple and it is very human friendly. So, it is in a way that the humans can actually write plain code which is very friendly, and it is much more readable for everyone to use and understand better for the humans. So that's what it is. It's much simpler to use. And now this, like an assembly language needs an assembler, here the high level language needs a compiler or an interpreter to convert your high level language code into a machine code. So therefore it might be a slow, but it's easier to write. The reason why it is slow is because you have added another layer on top, right? So there is also a layer on top where first your code gets compiled and it gets into generated into some other assembly code or whatever intermediate code, and then that intermediate code gets generated into machine code. So that's why there are layers, so hence it is a bit slow, but then it gives us a very good advantage for humans to write better code. Okay, and Java is an example of a high level language. Okay, so the compiler converts the Java code into bytecode and not directly into the machine code. We will discuss what bytecode is later on. Okay, so this is one example of a program that is written in assembly language. So it's just an example where it's a program to add one and two. So for that, basically this is the assembly code. Look at how there's four lines that you have to write even for a small instruction of adding one and two. Okay, and it is a bit difficult also. And assembly code is very much low level, very much close to the low level language, and it is not very human friendly also. Okay, and now what is Java? So now Java is a programming language. Okay, so a formal computer language which is designed to communicate your instructions to a machine. Okay, like we discussed already, it's a high level programming language, so it is very easy for humans to write code in Java. Okay, and now Java is not only a high level programming language, but it is also a platform. What do you mean by a platform? I'll discuss about this. So a platform is any hardware or software environment in which your program runs. In modern days, right, the operating system and your processor all together, we call it as a platform. And Java provides something called as a JVM. Okay, so everything runs on top of your JVM. Okay, so the JVM that runs on top of your hardware platforms, that is giving you a flexibility that your Java is acting as a platform. Okay, so Java is unique. It is both a programming language as well as a platform. Okay, so now what is a platform? Any hardware or software environment in which your program runs. So that environment or platform, that environment is called as a platform. So a platform is any hardware or a software environment in which your program runs. For example, in modern day systems, the operating system plus the processor is your platform. Okay, so this is your platform. Okay, now let's talk about why do we need Java. So before Java, right, we had C language or C++. These were the programming languages. These are also high level languages, right? So why do you have to come up with Java? So C language, right? The platform dependency problem. So the issue here is, so the source code that is generated by your C language, right? Let's say you have a compiler C1 or compiler 1, which is running on your Windows machine, and you have compiled that code and it gave you some output. Okay, or it gave you some output exe file or some output file dot a dot out or something. You cannot go and so this will work in the same environment. Like if the compiler is giving you the same output in the Windows environment itself, it will work in the Windows environment, but it will fail when you take that thing and run it in a other environment. For example, let's say you have a code and you have compiled it in Windows environment, and you took the intermediate code that is generated after compiling your program, and now you directly try to run the intermediate code that is generated in some other platform like from Windows to Linux. So it will not run in Linux because your C language, basically each platform needs its own compiler and produces platform specific code. So every time there is a code that is generated, the intermediate code that is generated by the compiler, that is always platform specific code. So this is a issue that code compiled for one platform does not run on the other. So this is a major issue which we had for C and C++. C. So C language problem, which is platform dependency, and why there was a need for Java. So that is a reason. So the same source code with the, let's say if it had like printf 1 plus 2, if this is the only instruction, this needs to be compiled separately for each operating system as well as your hardware processor. Okay, so for Windows compiler there would be a different exe file generated, and it will only work on this Intel plus Windows combination hardware. And for the Linux compiler, if you get the file something like an a.out file, if you want to run this, it will only run on a Linux environment with its corresponding chip where it got compiled. So similarly, it goes the same with the Mac also. So each compiled output only works in a specific platform. It is not only about the operating system, but also the processor. So the operating system plus the processor, which is our platform. So that combination of your operating system and processor in which you have compiled your code, it will only work in that environment only. So that is the issue. Now, what Java did is it came up with something interesting. So, Java compiler will convert your code, source code, to something called as a bytecode, which is like a dot class file that is generated by your JVM. Basically, this um, which is generated by your Java compiler. I'm sorry, which is generated by your Java compiler. The Java compiler will compile your program and then generate something called as a bytecode. Okay, and this bytecode is platform independent. Once you've compiled this, once you've compiled your code and it generated a bytecode, now you can run this bytecode anywhere. It doesn't matter. You can run this code anywhere. So now let's say um, because like bytecode is platform independent, that's where the thing, that's where it becomes easy. So Windows JVM will read this bytecode and it will run the code on Windows. We'll talk about what is JVM is a Java virtual machine. So every platform has a different JVM. Once you install the Java SDK, along with that you will get something called as a JVM. Okay, so let's say you have a Windows JVM. Windows JVM will still be able to understand your bytecode irrespective of from which source code, which platform, which operating system, or which processor it, or which environment or platform it was compiled from. It doesn't really matter. And even if you give the same bytecode to Linux JVM, it will still be able to understand it and it will run the instructions that are there in your bytecode on Linux as well. Even on Mac, it will be able to do it. So it means ki you have the bytecode once and you run it everywhere. So this is a very powerful feature of Java. This is the power of write once, run anywhere, which is WORA, which is write once and run anywhere. Okay, so that is a thing. And here's the same thing which is explained in a detailed way, that how is Java a platform independent, how is Java providing you platform independent behavior, that is write once and run anywhere. One compiler will run and give you the bytecode, and then there are multiple JVMs, as in like Windows JVM or Linux JVM or any environment's JVM can still understand the same bytecode, and it can run in all sorts of platforms. All sorts of platforms, as in the OS and the processors combination. Okay, the same level of line instruction which we were having in C++, which is print 1 plus 2, the Java compiler will compile it. It will give you the dot class file, which is the bytecode. And now this bytecode, even if you give it to Windows JVM, Linux JVM, Mac OS JVM, it will still be able to run it and give you the output. That's it for this video. In the next video, we'll continue about what is Java's history and its features. Thank you.